As you see, this is from PLTW and Boston University, so I use slides from them. This is unknown. There are three kinds of people in the world: those who can count and those who cannot. So, by using this joke, we will start our lesson. Why do we need to learn binary? The binary is used in digital devices. So as we see, is everything that we use uses binary, zeros and ones, but we are humans, we are using numbers. So we need to know the decimal number to binary conversion and binary to decimal again for ourselves. So in order to understand, we need to first ask, how do we count, or what gives a number its value? So we know that the computers use binary system, but what is really a number system? Numbers were used in ancient Africa, like notches on a bone, and Egyptian use symbols, and Indian Arabians use number systems. Why do we use base 10? If we happen, the basic system is we had 10 fingers, and if dinosaurs had ruled the world, they would have probably eight base counting system. And numbers we learned until now was natural numbers, 0 to anyone, and integers, we said it's all the full numbers, and rationals are the numbers that have roots, and negative numbers is the numbers below 0. Now, base 10 was taught to us is ones, tens, hundreds. But what is not taught to us is that ones was actually is 10 to the power 0, and that 10 was 10 to the power 1, and that 100 was 10 to the power 2. So we learned easily 1, 10, 100, 1000, and more, but in the background of the decimal system, it's all base 10. So every number, even 1, is represented in the powers of 10. And every time that I add a digit, it will be the powers of 10. So in this case, 10 to power 0 is 1, times 7 we said sevens, 10 to power 1 is 10, 10 times 5 is 5, we said 50, and 1 is 100, 157. So what is the base again? It should not, the base does not really, the base depends on the number system. So if we look at 642, base 10, it's 642. But if the base is 8, 642 doesn't mean 642. I need to understand, in order to understand the base, I need to understand the number of digits, the symbols to use looking at the base, and the values of this digit, which is the positional notation from the Edpuzzle video. Exponential powers depends on the base. So I created this 3 years ago with a discussion in the class. We said that the base, we come up with a rule. We said base cannot be represented in one digit. If you are in base 10, you can never show number 10 in single digit. If you are in base 5, you can never show number 5 in single digit. If you are base 20, you can never show the base itself in a single digit. And always, and then this base uses, base means base 2, base 5, base 8. So the circle represents a base. Always start from 0 for your numbers and exponential powers, and the numbers will go until base minus 1. So every number or every power, not the power actually, but every number or symbol can maximum go to base minus 1 because we start from number 0. So if I'm in base 10, we start from 0 until 9, which is base minus 1, 10 minus 1. It's like mod 10. You could maximum represent with minus 1, so it is 9. And for base 8, you could maximum represent 7 in that digit because you start. There's still 8 numbers in base 10. 1, 2, 3, 4, 5, 6, 7, 8. But you can never represent 8 in a single digit. The other rule is single digit representation. So whatever you do, you cannot represent a digit in a the multiple. It should be single notation. So if I go to base 16 or base 12, if I need to show number 10 and number 11, I need to use single digit. And and since I run out of numbers 0 to 9, then I start using alphabets A, B, C, so that the people are going to easily remember. And for if you run out again, if you go etc., there's like if you have a base 20, then this would go on to until that number 19 letter. And last one is base exponential powers goes to the base. So if I'm in base 16, every exponential power should be 16. So you could actually do, if it's base 10, you just place all the positional notation by 2 and start the power from 0, 1, 2, 3. And then that's, if you are in 5, you put all 5s, and then you start the exponential power 0, 1, 2, 3. So that's the formula that we come up with our class. Now, so what is base again? Base cannot be represented. If we are, right now, we are using decimals, right? So base cannot be represented as single digit, base 10, decimal. Always start from a 0, so the numbers are 0 through 9. Single digit representation, all of them are single digit. Exponential power goes, so we start 10 to power 0, 10 to power 1, 10 to power 2, 10 to power 3. So ones, tens, 100, and then what you do is you multiply the number with the base plus multiply, this is like a coefficient, multiply this number with this and add. So you multiply each number with the base and you find the number. So if I have base 12, let's just assume I have a number 152b and I want to convert this number to a decimal number. What should I do? This is a dozenal number. So British wanted to try out this number. So always start counting from 0, numbers 0 to 9. Now when I go to 10 becomes A because I run out of digits, and B becomes 11. And in this one, symbol characters, you could use any. And single digit number representation is done, and exponential powers now will go to 12 to power 0, 12 to power 1, 12 to power 2, and 12 to power 3. So then I will find these, and I will do 1 times 12 power 3. 1728. 5 times 12 power 2, 144. 2 times 12. Oh, I made an error here. If you see, it's supposed to be 12. And then B is 11 times 1. So please fix this errors for me. If you have a base 16, again, base cannot be represented. Base 16 hexadecimal. Always start from 0. Number of digits is 0, 1, 2, 3, 4, 5, 6, and then A is 10, B is 11, C is 12, D is 13, 14 is E, and F is 15. Exponential powers are your base starting from 0. Start from 16 and put powers of exponential powers from 0, 1, and 2. So, and then I will get F is 256 times 15. F was 15 times 256, 0 times 16, 5 times 1. Okay, and that I find F05 in hexadecimal means 3845 in decimal. So many calculation. You are tired, confused. Let's make it easy. Let's learn binary. So binary is super easy. You just need 2 numbers, which is 0 and 1. And computer is that. So you could have on and off. How do you show on and off? So if you use a button turn on and off, or you could say in electricity, you could show low voltage is 0 and high voltage is 1. And then if you are in radio frequency, you could show low frequency and high frequency. If you are in light, you could show again low frequency, high frequency. So if you are in magnetism, you could show north and south. So any of the medium, medium that the devices used can be easily set to 2 position. So now how do we calculate base 2? Base can be represented in 2 numbers, which is binary base 2. Now let's start. Digits are 2 digits, base 2, but numbers are 0 and 1. And single digit already, and we will start the base starting from power. So first we will put 2's. Then we will put the power 0, 1, 2, and then we will find the number. 1 times 2 to the power 2 is 4, 0 times 2 to the power 1, 1 times 2 to the power 0 is 1, and it becomes 5. What is good about binary is since it's ones or zeros, you can ignore the numbers. You don't have to even add these numbers when it's 0, and you only count the ones because it's just that number itself. So if I go here, it's like 4 plus 1 is 5, easily. If you look at this number now, so I have, if I look, I am going to ignore these zeros because they are already 0. So I'm going to focus on 2 to the power 6, 64, plus 16, plus 2. So that makes 82. There are, now your joke, there are 1, 0 kinds of people in the world, those who know binary and those who don't.